This video is going to cover the chemistry of water, which, as you may remember, water is a polar molecule. It has a highly electronegative oxygen, and it has two hydrogens. Now, hydrogen does not have as low an electronegativity as metals. However, it is low enough that it does not grab or hold on to the electrons quite as much as oxygen does, and therefore we have the Greek letter delta, the partially minus charge, and the partially positive charge for a water molecule. It is a polar covalent molecule, or a polar covalent compound. Remember that this line here means two shared electrons. One electron comes from hydrogen, one electron comes from oxygen. In this case, we also have, with the oxygen atom, we have two electron pairs that, because they are both occupying this space, there's no other possible way for another electron to get in there to form a bond. This is the reason why oxygen has one unpaired electron, another unpaired electron. Oxygen can make two bonds. And the actual geometry of the molecule is not a flat shape, but it's actually a three-dimensional shape. The oxygen atom being highly electronegative and the hydrogens being less electronegative means these permanent charges on the molecule will cause water molecules to be very sticky with each other. And when the hydrogen of one atom finds the oxygen of another atom and is attracted to it, this is what we call a hydrogen bond. This is extremely important for biology. Now, hydrogen bonding is an explanation for many different features we see of water. And again, this is what makes water such a unique molecule, such a unique compound, but it's really what the molecule that makes life possible. So in this case, first we see cohesion. Water molecules will cling together, meaning water molecules sticking to each other because of those hydrogen bonds, because of the partial charges on the water molecule. We saw this in the lab when we were dropping the water onto the pennies, and instead of the water droplets running off of the penny, they were clinging to the water that was still on the penny, and therefore that was causing the interesting phenomenon where we see lots and lots and lots of water drops bubbling up on top of a penny. Something we'll see a little bit later is the reason why the ability of water to stick to itself actually allows water to be drawn into plants, up the stem of a plant, and then eventually out through the leaves where it evaporates. That's something called transpiration. That's a vocabulary word you will need to see a little bit later on. Adhesion is when water will stick to polar surfaces. Glass, for example, silicon dioxide. Silicon has an electronegativity of 1.9, which is lower than the 1.2 of hydrogen. And the two oxygens are still 3.5, like they are in water. So that makes glass actually a polar molecule, which means that water will stick to it. And that's the explanation for the meniscus you would see in any graduated cylinder. We also see it inside of trees. The fact that water will travel up the stem of a plant, these things called xylem. The reason why is because the water likes to stick to the polar molecules in the cellulose, which is a sugar we'll talk about, or a complex carbohydrate we'll talk about. It's the ability of water to stick to polar molecules in the stem and the trunk of a plant or a tree. Now, the adhesion here is because the water molecules, the polar water molecules, like to stick to the polar glass. If this were a substance with a different form of force that's holding the atoms or molecules together, such as mercury, you would actually see a reverse meniscus. Mercury, being a metal and having metallic bonds between its atoms, actually does not like to bond necessarily to a polar molecule like glass. So the meniscus is actually reversed, where the metal, mercury, will actually like to bond to itself more than it does on either side of the meniscus. Now, an important thing about water is when it freezes, it becomes less dense. You can see here, there's a huge jump in density when water is ice, its density is 0.9 grams per cubic centimeter, which is lower than the liquid water 1.0 grams per cubic centimeter. So liquid water weighs about 1/10 of a gram more per cubic centimeter or per milliliter than solid water does. And that's why solid water, having a lower density, will float on top of liquid water. The densest that water gets is about 4 degrees Celsius. This is a huge and important phenomenon of water because water, when it freezes at the top and actually forms something of a protective layer, and will float, prevent the cold air from reaching as easily deeper into the water column. However, when water does freeze, it does just stay on the top. It does not sink to the bottom. If it sank to the bottom, it would be much more dangerous to life that lives in the water. I just thought this is an interesting image. This is what alligators do in ponds where the ice freezes, but they can still smash their heads through or keep their snouts above water so they're able to breathe. Even though the ice is around them, they can still breathe and they don't have to worry about suffocation. Another thing about water, because it is a polar covalent molecule, means it likes other substances that have charges on them. So we talked about ionic compounds. Now in an ionic compound, we have a full plus charge or a full minus charge. And these charges are permanent because an electron went from sodium to a chlorine. If you remember with water, the oxygen pulls on the electrons more, but does not take them completely from the hydrogens. This is a molecule because oxygen and hydrogen are still sharing their electrons. This is an ionic compound because sodium has given its last electron to chlorine. But we do know that because sodium has charges on it, chloride has charges on it, oxygen in the water molecule has a charge on it, and hydrogens in the water molecule have charges on it. Positive charges are attracted to negative charges, and negative charges are attracted to positive charges. This is why water will dissolve compounds like salt, because they have very similar charges. Water will also dissolve a substance like ammonia, another polar covalent molecule. Remember, nitrogen is highly electronegative. That means that it has a partly minus charge where the nitrogen is pulling harder on those electrons, and the hydrogens have a partly plus charge. When ammonia is in contact with water, they have very similar attractions because they have partially positive and partially negative charges. And this is why ammonia will dissolve in water. Now, the two vocabulary words you need to know: solute is a substance that is dissolving. So salt is a solute. In this case, ammonia would be a solute. Sugar can be a solute. Solvent is the thing that does the dissolving, that makes dissolving possible. So water is a solvent. In some cases, some alcohols can be solvents. Something like acetone, nail polish remover, is also a solvent. Water is called the universal solvent because many, many different substances, many different solutes dissolve in the solvent. So if I ask for an example of a solvent, water is a solvent. If I ask for an example of a solute, sugar, salt, something that would dissolve in water. Many different ionic, as we saw here, ionic compounds and polar covalent compounds will dissolve in water. Those are hydrophilic compounds, meaning they like water. Hydrophobic compounds would be things like long chains of carbons and hydrogens, oils, waxes. They do not dissolve in water because they are nonpolar. They do not have these permanent sticky regions on the molecule where a water molecule will be able to stick to it. So therefore, nonpolar covalent substances are called hydrophobic. They are scared of water. They do not like water. Something else we need to know about water is it has a very high heat capacity, which means it takes a lot of energy going into water in order to raise the temperature. If you've ever felt like the beach in the summertime, the sand might be hot, but the water is cold. The same sun is shining on the sand and the water, but the sand heats up because its heat capacity is not nearly as high as the water. Now, in the wintertime, we have the opposite situation happening. If you go to the middle part of the United States, it gets very cold in the wintertime. If you stay near the coast, it doesn't get nearly as cold because Water has been absorbing and absorbing and absorbing and absorbing heat over the course of the summer. And then in the winter, that heat takes a very long time to come out of the ocean. And therefore the coast, somewhere like New Jersey, in the middle of winter is much warmer than a place like Iowa in the middle of winter, because Iowa does not have a large body of water to moderate its temperature like that. Also, because it does absorb a lot of heat in order to evaporate, it's great for removing heat from our body. So mammals sweat because water absorbs that energy, takes that extra heat energy, and makes the water evaporate. One other thing related to cohesion, because water likes to stick to itself, water has very high surface tension. That's on the surface. It's almost like a skin where the water molecules are attracted to each other and holding each other together. It makes it very hard for objects to push through that surface. So if you dive into a swimming pool, jump into a swimming pool, you feel that whack when you hit the surface tension. Many insects are able to actually use surface tension to their advantage and skate along the surface of a pond. Now, another thing you will need to know as part of biology is the water cycle. Many different things are recycled through an ecosystem. The water that we drink has been drank by many different organisms before us. And then that came out of animals as urine, that came out of animals as breathing. We breathe out water. Whenever we breathe, you breathe on a mirror, you breathe on a piece of glass, you can see that condensation. And then that water will end up as possibly runoff. It would go into a body of water, maybe a lake, maybe the ocean. We probably know the word evaporation, where energy hits the water. Some water molecules come from a liquid and turn back into a gas. We have evaporation when this water goes high enough, the water as a gas goes high enough, it gets cold up in the upper atmosphere and it condenses, so we have condensation. We may have additional evaporation from the clouds, that's possible. Transportation, the clouds blow around. But the words we really need to not worry about are precipitation, evaporation. Precipitation is kind of the opposite of evaporation. Condensation, so evaporation is when the water is turned into a gas. Condensation is when it turns back to water. Precipitation is when that water falls down. We have plants taking up water and releasing that water as transpiration. Sublimation is when solid ice turns directly into a gas. It's not going through a liquid form. Deposition is when when gas turns into a solid directly. So, for example, way up in the mountains in Wyoming, when it gets 45 degrees below zero, if you're at 45 degrees Fahrenheit below zero in the wintertime, extremely, extremely cold, the water vapor that's in the air turns directly to ice and then just completely deposits onto mountains and other places in the Rocky Mountains, the highlands. There's not just mountains, there's also high plateaus and things like that up there. So we get basically the ice just forming out of the air and then ending up in ice deposits as deposition. So here are the definitions you need to be familiar with. These are definitions that you will have to label on a water cycle chart. So they're going to be useful for biology. They will also be useful for chemistry. So we have our condensation. Condensation is when we go from a gas to a liquid. So what happens in the clouds is condensation. Evaporation is when we go from the liquid to the gas. So that's what would happen on the surface of the ocean or the surface of a lake, or the sweat on our skin also evaporates. Sublimation, this is when we're going from ice, solid water, into straightly to gas, just water. Dry ice, if you've ever seen that, dry ice also sublimates. Dry ice does not pass through a liquid stage at Earth's pressure. It goes straight from a solid to a gas. If you ever open a freezer really quickly and there's kind of condensation that comes out, that's because ice cubes in the freezer have sublimated a little bit, and then that water vapor that came from the ice into the air now comes out of the freezer and condenses as tiny little droplets of water. Deposition is when we go from a gas to a solid. So again, we see this in a freezer. If you let the freezer go long enough, you'll see ice crystals that are deposited on the outside walls or the inside walls of the freezer, and that's deposition. That was probably some ice in an ice cube tray that turned into a gas, and then that gas touched the side of the refrigerator and turned back to a solid. There was no passing through a liquid stage. Transpiration, this is out of the leaves of plants. This is when water molecules leave the leaves of plants and end up in the air. Some very similar evaporation, but because it's happening in a living system, we call it transpiration. It happens in plants. Respiration, when we breathe, when humans breathe, we release water into the air. We release water vapor into the air. When most animals breathe, they release water vapor into the air. And then perspiration is something that mammals do. Many different kinds of mammals sweat. That's where you're releasing liquid from your skin that ends up evaporating. Try to cool yourself down. Many mammals can sweat. Not all of them do. Horses can sweat. Humans can sweat. Dogs can't sweat. Dogs pant instead. But definitely you don't see any reptiles or birds sweating. It's pretty much just a mammal phenomenon. So that covers all of the information you need to know for water. And I will post the CK12 connected to this. And that will be in a link. This will be in a link on PowerSchool, but the CK12 will be titled, like the title of this, Chemistry of Water. That will be the title of your quiz that you will have to answer on CK12, which will make sure that you're familiar with this material.